Yeah, hi. So today we would like to see this coding problem of finding the longest palindrome from a given string. So here is the given question. So this is the given string input ABC XY Y XF, and so the question was, what is the longest length of the palindrome that can be generated from the given input string? And the answer for this is x, y, g, g, by x. So this is the palindrome. We can generate one more palindrome to a, b, a, but that is of smaller length. Okay. So this being a string problem, how to approach this problem? Okay. So one common thought that just arises is simple way of logic is just iterate, just make the substrings out of this by looping twice, like keeping the I and j pointers, something kind of, and looping twice on this string, and just check every time whether that substring is a palindrome or not. So as we already seen previously, so palindrome checking, the best way that we found was done using big O of n time complexity, and space complexity is big O of n. We are not currently concerned about the space complexity. Regarding the time complexity, so the best way that we did was using the pointers like left index and right index, and we calculated by n by 2 times looping, and it gave a time complexity of big O of n. So if you just iterate twice into this given input string, and finally it would become n cube complexity. So so instead of going with n cube, so is there any better way of solving this problem? Yes, absolutely. So how can we do is, instead of what we are thinking is, so we are thinking in such a way that there need to be a, like, substrings need to be calculated, and the palindromes has to be checked on each substring. But yeah, in that process, actually what we are taking two pointers like I and j something. Instead of that, from the basic logic or basic definition of a palindrome, so there is two types of, we can say, like, x y x is a palindrome of odd length. X is a palindrome of even length. So if you see here, either the middle pointer will be there, and the left index to the middle pointer and right index to the middle pointer elements would be become equal you know in odd length of a palindrome. If it is even length, just there will not be anything in the middle. Just um, the these two characters would be equal. This can be anything like x y x, anything. Okay. So what I mean is, instead of going with pointers at the end, start with the pointer with the middle. Start with a pointer. I mean, take a pointer at, say, for example, this element, and check on the left and rights instead of coming from left and rights to middle. So start with the middle and go to left and right. So that would actually reduce the time complexity, and it would bring around n square complexity just for the whole problem for this, if you do in that way. Okay. So Okay, so the input string given is ABXYZZYXF. Okay, and consider it as string. And okay, so if you want to implement this definition, find the longest. The logic was just told that okay, start with your pointer and go to check the elements on the left and right. If it is even, check just the current index and index to its left. Okay, so starting the implementation, longest palindrome. So it will take this string. It will just take the one string as input, and we have got this string. And how can we go further is I will just create, I will assume that there is, because I am starting with indexes or pointers. So I will just create a new index called long longest palindrome. Longest palin. Okay. So in this variable, this actually won't consist the actual string. It will contain the indexes of the string. As we know that, say for example, initially a, say for example, a is always a palindrome, because if you reverse that, it will be a, and it is a palindrome. So start with that. The longest palindrome, we initially take that as 0 of the index, 0 index, and 1. So I am taking the, you can think this as left index and right index. Okay. So yeah, I mean this variable doesn't hold mm, any actual strings. We are now just to deal with the indexes or pointers. So in that way, we will proceed for this implementation. We got the we initiated the longest palindrome as 0, 1, and we can iterate. Now we can iterate through the string and check for I in range. So the maximum it can go is up to length of this given string. As we know, we have already taken the 0 into consideration. No need to check further. Just start with first index up to length of the given string. You need to iterate. Okay, what we can do at each iteration, we need to check whether any even indexes, as we talked, a, b, a, this is odd, so a, this is even. So we need to calculate the possible ways of even and odd indexes. So I will take even indexes. If it is even, what would be the, we need to create something like this. Just the indexes, left index and right index. For that, I will create another function, call a new function, that is like get palindrome indexes. And what I need to pass is I need to check actually. So is there any for even what I need to check? If the if the existing I, if you want to calculating at a index I, check if I minus 1 I is, you need to check for these two indexes whether is that a palindrome. This checking of the palindrome will happen in this new function. So definition get palindrome indexes. This will provide the indexes if the taken string with these indices is a palindrome. I'm going to pass the input string. I have to pass definitely the input string for checking, and I will pass two more parameters, that is as I just talked, I and I minus 1. What is this I minus 1 and I? So this is left index and right index, that for a even string. Similarly, for odd index, get palindrome indexes. Same, you need to pass the string, the given input string, and call differently. That is, if you are calculating at the I, at index I, you need to pass the left index as I minus 1 and right index as I plus 1. That's what I'm going to pass here. I minus 1, I plus 1. Okay. So this will take this parameter string and left index and right index. Okay. What it will do, it need to check whether it is a palindrome or not. Okay. So while what I will check is initially, because I am actually dealing with the strings using the indices, so I need to check whether that should be within the index, within our range, because if that is not the case, it will provide a out of the bound exception. So while I am initially checking whether left index should be greater than or equal to 0, isn't it? And right index less than length of string, isn't it? Length of the string. So after checking the whether the given the past indexes are within the range of the given string, so then what we need to check? Okay, if it is checked, okay, if the string of left index, because in these cases, in making these while loops, first actually we need to write the condition which fails. That is, if the palindrome is, say for example, a and a, we shouldn't check whether those are equal or not. We need to check that the characters are not equal. In that case, we can stop that further recursions, further iterations. So I'm checking if the string of left index and string at right index, string at right index is not equal to. If that is the case, what you gonna do? You need not to do anything. We are just trying to find the indexes, and if the characters on the left and right are not equal, just break out of this loop. Okay. Okay, if this condition is not satisfied, and the characters on the left index and right index became equal. So in that case, you need to go further checking, that is updating the left index. uh, as we talked, we will take the pointer in the center, and we will expand on the left and right. That is, the left index will be decremented and right index will be incremented. And right index will be incremented. Okay, so when this will while loop break, either if the characters are not equal on the left and right index, or this checking has been completed. If this checking has been completed, I mean, if the character goes out to the extreme left or to the extreme right, say when it's going to at that moment, so the left index would probably be uh, -1 if it crosses the 0. So either it can be -1 or length of the string. Those are the two possible cases. So then what we need to return? We need to return to this position, that so to say that this even and odd indexes just carries the indexes, just like this 0 and 1. We need to return the indexes, that is return left index. Hmm, yeah, say as I told just now, that if it is crossed, it will break this while loop. If this condition fails, that if left index became -1, we need to add +1 to that to make it to just return 0. So I am adding +1. And do we need to return, do we need to make any change to the right index? No, because so as we know in Pythons, that in Python or in some language, that if you pass, say for example for a string 2 comma 2 is to 2 is to 4, a what is that, a clip or mm, some making of a substring out of this string. So in that case, actually you will get the second index and third index. You will not get the fourth index. So you need not to bother about modifying this. So I mean, so because of which I have just added to the first index, changed the first index, and not changed the last index. Okay. Now by calling this function, we got the this indexes, left index and right index. Okay. So after this, how we need to proceed? We want to finally calculate the longest palindrome, right? So the maximum length of the palindrome, max palindrome. I'm creating this variable. Max palindrome would be what it would contain. It would get the best of even or odd index, odd strings that we got from there. Yeah, that's it. So we need to call this max function. Max, you need to pass these two indexes, even and odd. Okay, and as you know, the max index, we are passing, say for example, we are passing some 1 comma 2, 3 comma 5. Say for example, I'm just assuming randomly. So how will you calculate the which one is bigger? We need to provide a key to the max function, and what is that key? It is a lambda function, lambda, which as lambda is just nothing but a inline function which we can write in a single line instead of writing as a separate function. So this lambda function will take a parameter something like x, and it will, so when x means this is the x, so we need to subtract x1 means this x1 minus x0. So what this will do, it will calculate the even and odd lengths by calculating the x1 minus x. So this will give 1, this will give 2. So this will become max for this. Okay, so we got the maximum palindrome by comparing the even and odd positions. But we need to compare still a like uh, the latest max palindrome, or we calculate it to here. We need to calculate the current longest palindrome. Current longest palindrome. What it will contain? It will take this max palindrome and the current longest palindrome. So it will check this max of max palindrome and the longest palindrome. Longest palindrome. Similarly, for this will get an index. This already has an index, just similar to above. We need to write key is equal to the inline lambda function x is to x of I1 minus x of 0. Okay, so this finally this will has the final index which contains the longest palindrome. So we just need to return that palindrome. Those are just the indexes, so you need to call those indexes on the string. So return, we need to return the actual string, not the indexes. So just call on the string mm, the current this you can shorten this as CLP, current longest palindrome. CLP and CLP of this will contain, say for example, 1 comma for this, for actually this is 0 1 2 3 4 5 6 7 8 9. So you need, this will contain actually after executing this function, this will contain 3 and 3 and 9, 3 and 9. So the substring would become 3 to 8, 3 to 8. That is the maximum possible palindrome out of this given string. So we need to call LCP of 0, LCP of 0 and 1. Did I write correctly? LCP of, we are passing we got LCP CLP string of LCP of 0, which will give 3, to LCP of 1, which will give 9. This will become, so string of string of 3 is to 9 for this given string. So I think that's it regarding the time complexity. So what is happening? It is running in as it is iterating once here and calling a function there. It is making a big O of n square of time complexity and space complexity, which is equal to, it is creating, it is not creating anything, so it is of big O of 1 space complexity, so best complexity for space. So using pointers we finally got that the possible best complexity n square here and space complexity as big O of 1. I think that's it. This completes the problem.